Hey everybody, this is Larry. This is the Biweekly Contest 162. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's poem. I'm just getting my book or my notebook and pencil ready. Yeah, let's get started. Man, busy day, so let's go. Go. Do. A lot of loading. Hope everyone's having a good day. Let's go. Alright. Land rights and water rights. Okay, earliest time. And this is a part 1, so this is also part 2. Okay, I don't know if that matters, but how long I've. Okay, earliest. Okay, one right from in either order. Okay, tourists can finish both rides, right? I just one of each one, right? And M is 100, so we can just force this, right? It's a bit annoying. Is this easy? I don't know. Maybe it is. I mean, it is definitely easy. It's just annoying to write, maybe. Right. So then now you start at either. Do you want to always start at the min? I guess it doesn't matter. So you just brute force. Oh wait, no. So this is the I mean, it's not okay. It's just really annoying. I'm actually surprised it is and easy unless I'm missing something. Basically, we go okay. So len if water start time j is greater than you go to len n. If it's before. If its start time is afterwards or equal to, then best is just equal to min best water, and if it is before, then it is still no, that's right. Okay, else best is equal to min best len n plus water duration j. Okay, that's where I was confusing. And then now we try the other one of len. See, I don't know. I mean, it's very easy to get wrong as well, right? Like just typo if nothing else. Len n plus len duration of I, right? And that's it. I mean, it's not so bad, but a lot of 9 and 14. Okay, YOLO submit. Hopefully I didn't miss anything. Okay. Okay, let's go. Q2. Minimum. Alright. Am I recording? Okay, yeah. Any number of nums bound to divide the maximum at most k times. Okay, minimum number of. Just sliding windows, right? Maybe in binary search. Okay, so not so bad, right? And then this is the start. Maybe we can call it left. Right. something like that, right? Maybe off by 1. This is inclusive. So do we move to rest, right? Is that right? Feels a little weird. Okay, so inclusive. So you're removing all the other ones. So is this off by 1? Oh, bisect right. So that's why, because this is should be did. All right. I forgot this. I mean, it's maybe equivalent, but it's linguistically is if you have run into an issue that's like a really bad debug case, even though they are equivalent, possibly. Maybe there's an off by 1 somewhere. But that's what I mean by debugging. All right. Now this is a big N. Same one with Q1. Sliding window. I mean, sweep line on one and then do the other. Right? We would do it both times. Okay, fine. Yeah. Whatever. We'll sort by start time. Yeah, maybe what to do. Okay. So then all the ones you pass, and all the ones that you passed, it is just the duration, right? And then you're going to take a min of that. Okay. Maybe. You want to sort by not this, but okay, yeah. You want to sort by okay. Maybe we have to sort twice. I think it's fine. Actually, maybe. I was going to write this twice, but okay. So then now, okay, so the start time is less than or equal to length n, then we only care about the duration. Start time duration. And then we have a best duration, maybe best previous is equal to infinity. And now we say best previous equal to previous t, right? Something like that. Okay, and then now. Okay, but then now we have to consider, if it's afterwards, then we just consider the suffix, right? Earliest end time of the suffix. I mean, we have to pre-process, that's fine. It's just really annoying to do. And I didn't do it yet. Best end time of the duration. How would I store that? I mean, maybe just another key. Yeah, okay, fine. We'll just a little bit rewrite then. That's fine. No, I mean, yes, fine. Okay. I'm just naming random variables at this point. This is going to be dubious, but okay. All right. All right. Okay, and now we sort by, where's my sort? Oh no. Did I sort this way? This is sorting by the end time. So this is actually, we already did the math now. So it's 2. Yeah, okay. And then we want to sort this by the start time, which is true. And we keep track of, because everything afterwards just matters the end time, right? So we can put everything in a set, I guess, yeah, or a counter, or a sorted list. Okay, fine. I don't think this is necessary, but just keeps it easier for me to do it faster. Okay. And the reason we do that is we want to get the earliest end time. These are all the possible end times. And then now when you pop, you also pop. This is the duration, but then now you also pop. And then now you can get the min like a heap. I guess it could have been a heap. It would have been a tricky heap. Lazy heap. I guess that's what I wanted. Okay. Okay, so it's okay, so this is the best previous. So then now it's going to be LAN and bus. The notation, the camel case and the other thing is mixing up. Okay, so it's either that or that's the latest end time for the rest, right? So then we want min of this, and then that's it, right? Okay. And then now we want to calculate for land water. And just swap the order. Right? Did I mess up? Oh, I call it Z was SIP. I don't know why I have it R here. That's not great. Oh, that means this is the last element. So okay. Okay, fine. I think this is right? I just want to double check. This index here is kind of weird though. L, did I mess up L? Oh, because I swapped backwards. This should be here. Uh, 914. I think these are the same input. Oh yeah, I forgot that I can use this on Q1, right? It's a trick that I haven't done in a while. So let's give it an easy freebie. Okay, I mean, easy freebie done. What is this? Is this Q3? Yep. Hope I didn't make a silly mistake on this one. Or timeout. I guess it could time out. But alright. How are we doing on time? Wow, a lot of people got a lot of this, so I'm not doing so well. Slash, you know, a lot of people are cheating, but that's besides the point. Well, I mean, this is because everyone finished Q4 first, right? Before I even looked at the file. The leaderboard, I don't know how they regress, but anyway, okay. I digress on the regress. Alright. You can enter enums, queries. Left right threshold. Return where answer sub I is equal to the element in the subarray that appears at least threshold times. Highest frequency, the smallest. Okay, what does that mean? Okay, yeah, sub. What is sub? Oh, 0 and 5. Threshold is 4. Uh, 10 is 10 to the 4. Is it finally time for square root decomp? I feel like every time I try it, it's a little bit too slow, but that's usually 10 to the 5th and not 10 to the 4th. What's that, 10,000? Maybe that'll be fast enough. Let's see. A little hesitant because it is still very annoying to write square root decomp. Yeah, okay, fine. Square root decomp, how does that look like? I don't know how to write this anymore. It's been a while. I don't know. I don't know how to write this. Just say. No, I want size of the piece to be this. Is easier. Is it? Am I just overthinking it? Is it? I mean, there could be a lot of unique numbers, right? 10 to the 9. Threshold doesn't, yeah, fine. Threshold's pretty standard. Yeah, okay, fine. Man, so many people got it so fast too. I mean, okay, I always forget they're cheating. How do I even want to pre-process it? So we pre-process the first, or just order the square root. So L chunks, is that it? No, okay. I don't remember how to write it in a good way, so I guess we'll just have to do it in a dumb way. Actually, maybe something like that, and then we're going to do something like something like this for the frequency table. frequency table, but we should probably do a trying to think through the maths in my head, because we could have a lot of unique elements. Is this right? Does that even make sense? Because then you have to merge the frequency tables, and that's just not right. So if we force everything on the square root, the idea is that, but if each of these components have square root of n pieces, then the merge so each query is not square root of n anymore, right? You need to be able to do it in over one-ish to make it square root of n per query. That's not quite right. Even if it is square root decomp, that's not the way to do it. Oh yeah, I guess we could pre-process the queries. I always forget that. Maybe. Oh, enter in a different order. Can I do it in different order? I don't know. There's a sub-array things. Is it over weird? Sliding window or sweep line on sub-array? Does that even make sense? I don't know. I don't think so. I mean, apparently a lot of people know it, so either people are very smart or they're just very Googleable. How would I write this? I don't know why I'm stuck in square root decomp. Let's see. Yeah. Is it just sparse table? No, that doesn't make sense either, because you have log n, and then with each of those pieces have. Where is it? No, because if we do sparse table, each grouping each level will have at most n elements in total. So, oh wait, no. But then the problem is that you don't have. Are you just segment tree? But it's just another data structure problem. Can I do anything with frequency? How much time do I have left? Oh wait, I guess. Well, within a sub-array, only the highest frequency matter. Slash typewriter, right? So you don't really need everything. Because, okay. No, you still kinda. You can merge stuff because you could get caught up. But it is true that only the highest matter. And I take advantage of that. The threshold doesn't do anything other than an if statement, does it? Oh wait, no, no. It always just you always choose the highest frequency. Though none of these examples really show that for some reason. Oh no. Yeah, no, this is So you definitely choose the one with the highest frequency. So the threshold doesn't matter. Okay, so the threshold doesn't matter. I don't know why it took me so long to figure that out. So basically you want to get the max element in a subarray and then being able to get the frequency in a subarray. The frequency is pretty okay to get if you're able to get the max, right? I don't wonder if there's anything with what's his name, Freud or whatever, Warshaw's? No, some dude's majority algorithm. No, but it doesn't give you the. I mean, it gives you the majority, but it doesn't give you the mode, which may not be the majority. Why do I not know this? Can I do the queries backwards? Because the threshold doesn't matter, so now we have just these windows. So because the problem is when you do a scan, it's going to be square root of n, sure. But then you merge them, it's not going to be good enough. Well, I guess I can solve it in square root of n times log n, because basically you only keep track of the most popular element, and then you do a binary search, and there can be only square root n components. Maybe log n of them if I do it log n. No, square root of n makes the most sense. But what is LCA most? No, least common, no, but what we want is the can we do sparse table? So basically sliding window on, then you just have to do 3 queries. That'll be fast enough, right? And you don't even use the sparse table, right? Though you can. Well, I mean, the sparse table doesn't do anything, but we can do it with square root of n. What is log n? Is that gonna be too? Is that fast enough? I think that's right, but I don't think it's fast enough. So I have an n or q log square n algorithm. I guess that's where, but square root of n is going to be slower. So square root of n times log n is also bad. So no, that's not right. The problem is that, oh no, is it pigeonhole? I mean, it would be pigeonhole if they're disjoint sets. But if they're joint sets, there's log n of them, so log square n. Because if there's an intersection, then the pigeonhole no longer holds. Okay, I buy that. Okay. I don't know. I don't know how I feel about this far. I don't think it's going with decomp. I was hoping, but maybe not. Okay, very fast. I have 58 minutes. I think I'm okay. I've spent 50 minutes thinking about it. Alright, so then what do we want to do? Sparse table? Okay. I forget how to do sparse table. I have code, hang on. I don't think it's the code for this though. Oh no, my thing is down. I can't find. I should just write. I mean, at this point, I'm not. I'm not saving any time looking for old code. Not to MFA. Okay. Okay, I can't find it. Okay, so then let's just say. I guess we can just keep going, right? So we have. So then now this is for one element. Alright, so then and then we have let's see. My site file loaded. I forget how to do. I mean, I don't forget, but I'm trying to write it not in a dumb way. I guess I did not implement this in a not dumb way anyway. All right, so then here we have what do we want to say? Okay, so this is link 1. Right, so for range of from 0 to n minus 0, right? So we want to sort of this. This is so expensive though. Actually, isn't in collections or in counter most common? I wonder what the time complex of the most common is. Most common is O of n. That's useless. Yeah, that is useless. Basically, we just want a heap, right? Alright. Okay, and now here, I guess technically now the way that we wrote it, this is going to be 2 to the L or the L. This is wrong. Nope. And then now, and then now we have f of num sub I with s something like this, right? And oops. No, this is the last number. We want it this way. It's greater than 1. Something like this, right? And then now we want to get the min. No, we want to get the max. So that is frequency x. Then now do we need the frequency? Maybe we don't. I don't know. Do we need a frequency? I don't know, but yeah. Then now st sub L, I'm gonna append x, right? That's basically the idea, just having the frequency things. Is right. a spin, see if it crashes. Oh, I forgot to append an empty thingy. Okay. Oh, L is 1, that's why. Is it L minus 1? Yeah, I guess so. Well, L is just 0, actually, because 2 to the 1 is... Okay, I'm just dumb. Okay. Is an F a counter? How can it go out of bounds? Oh, nums of I can go out of bounds. Oh, oh, this is could be smaller than n. Oh, this is just wrong. This is... Oops. Maybe even equal to... Actually, I don't know. I think, whatever. I don't think that's too much. Okay, it runs very slowly, maybe, possibly. How long does it take? No, just Leetcode being Leetcode things. Okay, so let's spot test. So this is... No, for L is equal to 1, this is clearly wrong. This should be the initial array. So that's not great. Oh, I didn't subtract from the... Okay. I knew I wanted to do that. It's so expensive. Okay, fine. I mean, this is right. It's just I don't know that this is going to be fast enough for this. I mean, this is by definition should be true, but okay. Oh, still wrong. Even with the document. Double check. I'm missing an element, so there's something. So if I is 0, this is going to be 1. Okay. Should be wrong. Oh, I forgot the initial one. That's why. That I actually knew. I was like, remember the initial thing because you did it in a weird way. Oh, so this should be... I wrote L here, but I guess it should be just the biggest one. Doesn't matter. Okay. I guess just here. Okay. And this is off by 1, but so it's no good. Why is it off by 1? 1, 1, 2, 2. I mean, this is right. So then why is it... did I mess up something on the SL -1? Well, maybe SL is not right then. Oh, I'm doing the wrong thing. Okay, 1, 1, 1, 1, 1, 2, 1, 2, 1, 1, 1, 1, 1, 2. 2, 1. Oh, maybe that's the next one. Yeah, okay, fine. There's only 6 elements. So then why is this giving me wrong answer? for this. Oh, because I did this before I remove. I need to remove first. Dumbo. Come on, sliding windows, basics, Larry. Okay. 1, 2, okay, so that's good. This is of length 2. Oh, and I got the tiebreaker right. Nope, I do not. Choosing smallest number. Nope, I do not tiebreaker right, but that's fine. That's an easy fix. Yeah, okay, so that should be a 1. This is a 2. This is a 1. This is, so then it should be 1, 1, 2, 1, 1. And then for 4 elements, this should be a 1, 1, 1. Right? Okay. That means that we have the tie break on. It's actually kind of annoying. I mean, it's fine, but annoying. The key just has to be all negative. Okay, so that, now this is where we want double checking real quick. 3, 2, 3, 2, 3. Okay, well. Okay, so then now. Okay, so that's the first table, and then now I don't know if this is fast enough, to be honest, but we'll see. Maybe I should have done it in another language. Yeah. Okay, so left, right, threshold. So then now you have all these pieces, right? Yeah, okay. Maybe C for consider. So then, how do I do? I always forget how to do the binary merging things. I guess it's not that bad. It is. Basically, you want to get the length. The length is going to be right minus left plus 1. Yep, okay, that makes sense. And then now, in terms of max L, which is, I guess L is actually the biggest number so far. Okay, so this bit is, then we have to take the progress from current left. Something like this. Am I doing it right? If I 0, the 1 is 0, we move over 1, we get a consideration of, I guess it should be a set, just to make it slightly faster. And then it is the st of I, and that's it actually, right? No, st of I of current. Okay. Right, and let's see real quick. I don't know if this is right at all. Okay, actually. Yeah, okay, fine. I'll just print C real quick. So that it. Okay, let's get rid of the other print statements real quick as well. Dunk. Is that it? I think I have one more spot, right? Maybe I don't. Nope, I do have one more spot. It should be here somewhere. Oh no, it's oh. Oh, is that the end? Is it? Oh no, I print this. Okay, so that's fine. Actually, that's intentional. I'm dumb. Okay, so 1 1 1, right? 0 5, it's 1. Okay, 0 3 is 1. That should be right as a consideration because that's perfectly 4. And 2 3 0 1 2 3 0 1 2 3 is not right. Okay, that's a little bit sad. Why? Why is this not a 2? Okay, let's print ST again just to make sure. So it should go. Okay, the number is 2. Oh, I don't have the L. No, that should be fine. Update current. Alright. Oh, current is 0. I'm dumb. Zero's left. What am I doing? How did I don't know how that happened. Okay, so this is expected. Okay, alright. I mean, I still don't know if this is right, but it's looking better. Just comment it out. So then now these are reconsidered. Now the other part is just more straightforward processing. I actually, I mean, I didn't forget per se, but I was like, oh, I'll hold it off until later for some reason. And again, I don't know if this is fast enough. It's gonna be n log square n. Okay, and then now. Best is equal, best count is equal to 0, best index, or best number is equal to also 0, say. Is 0 a possible input? No, okay. Negative 1 if none exists. I guess maybe we just put negative 1 if 0. But okay, so then now we do f of x oops, of inclusive, okay. This goes to the next one, so I think this should be right, right? Oops. PC is greater than equal to threshold. Did I just call threshold? Yes, but spelled correctly. Then yeah. Alright, I mean, moment of truth. Or a preliminary moment of truth, okay. By d f of x, right? Oh, it's not f of x, it's index c's of x. Okay, not that bad. One negative 1 2. Again, I don't know if this is fast enough. I would do a big number test, but I don't even think it matters that much. In a sense that I don't know. Oh, that's actually surprisingly fast. I guess it's all ones, that's why. So maybe x. So something funky like this. So it's all unique numbers. Still pretty fast. And then what we want then is queries. Whatever, it looks fast enough. I mean, it may not be fast enough, but it looks fast enough for me to kind of YOLO submit. I mean, it was still too slow. Oh, just wrong. I mean, this seems clearly an off by 1 situation, so that's fine, maybe. I should have tested this case though. This feels like a very testable case. I was worried about TLE. Why am I getting wrong here though? It's fine. We have 34 minutes, actually not too much time. But oh. Did I click on the right button? I think I did. Okay. Oh, we just don't construct. Okay, well, that would do it. Let's see. I guess this is where I forgot to test that case. Well, I was like, oh, I can do it later, but then I just forgot. Or I forgot to check if I do handle it later. Because there was a moment. Is this still right? Just want to make sure for the other ones. Yeah, look okay. No timeout, please. I also wouldn't be surprised if it does. Oh, wrong answer. It's surprising, actually. I mean, it is based on pigeonhole, so 12. Which one is wrong? Okay, so 0, 1, 2, 3. I can't believe it. I mean, maybe it's just wrong. 0, 1, 2, 3, 4, 5. 0, 5, 2. 0, 5. Okay. That seems pretty reasonable for me to, or should have been right. Maybe I'm off by 1. 4 and 2, right? Where's it go? So we're looking for the 0, 5, 2. 3 and 12. Why do I not consider 10? Oh, maybe there's some weird tie breaking thing. Oh, because of the tie breaking within a number or within the range. Huh. Okay. So if that's tough. Huh. So this would work if there's no. Well, that's not even true. But I think my pigeonhole was just a little bit off as a result. Because now you have 2 numbers that are both contending, and I just picked 3 instead of 10, and because I picked these 2 as chunks, and then as a result, the 10 gets split up in the tie break because of the tie. Oof. I don't know if I know how to fix this. And this is already kind of tight on timing, right? How much did it take? I mean, there are different combinations, but that's just so tricky. Huh. How would you do it? Oh, that is a bad input, or like a bad input for me. Perfectly, and I don't know. I just take so long to load. They're just looking at my submissions from like the last 5 minutes or so. Would have been good. Okay, well, I don't know what Leetcode's doing half the time. Huh. I mean, the problem is that anytime there's a tiebreaker, that's going to happen. If you just pick the wrong one, what you need for majority is that you can sell all of them. Unless there's like a... Oh man, I really did not consider this one. I don't know why Leetcode. Can you do your one thing right? Yeah. Because I'm just curious about the timing. And it doesn't say here for whatever reason. I don't know now. I mean, I don't even know if any reasonable processing this can, you know. I was thinking there are log and chunks, do log and work on log and do. But because they're tied, I mean, that's not even a thing, right? In the sense that you add one more number and then it goes to, yeah, like if it goes from, you know, this num, except for this one is a 10, then in that case, you would still have the same issue depending on the order in which you process these chunks. Wow. Wow, I mean, I have no idea how to deal with tiebreakers. I mean, the other input was dumb for me, but this one I actually don't know. That's terrible. Like, there's no tie-breaking rule that makes sense. For me, I mean, in a greedy way, you have to consider all of them. And then at that time, yeah, and then you just have an entire input of unique numbers, then you have to go through all of them every time, and that is just slow. Huh. And today I am not able to solve any problems. problem is that if you just use chunks of 4, like you do here, and then you can still kind of get lost in numbers. Is that true? Yeah, because imagine you have the basically my sparse table is just candidate thing, right? So we have to figure out how to get more candidates. The problem is the tie breaking. The idea is conceptually okay, I guess. Maybe not anymore. Just one of those days, I suppose. Even with square root decomp is the same thing, isn't it? At least the way that I'm thinking about it. Maybe there's another way of thinking about it. I mean, I don't know. I don't. Yeah, and try to prove from first principles. Yeah, maybe it's time to retire. Hmm. Hmm. Yeah, I have no idea. I think the worst part is that this is private Googleable, which is why so many people got it. It's either that or it's just like a textbook thing that I don't know about. I mean, 10 to the fourth usually it's like a square decomp thing, but maybe I'm just not understanding what I need to do for a square root decomp. I don't know, maybe I could get away with n log square n, but then there's this thing with uh, no, that's too big. It's gonna be an n over 2. Each of these, or is n over 2 is n minus 1, and each of those has 2 elements. That ends up being n squared, isn't it? Yeah, okay. Now that's n squared. It was 7:20 and then go for my run. I have no idea how to do this. Anyway. Not gonna lie, I am just reading up on square root decomposition and wondering if I'm missing anything. In case you're wondering, I mean, I don't know. I don't know how to solve this one. I think it's either square root decompose sparse table. None of the complexity really makes sense otherwise. Maybe segment tree if I don't know it, but yeah, we have another 12 minutes. Might as well use it to learn. Let me actually screenshot the leaderboard real quick for sadness. But that's what hey, that's the issue I'm having. At the more of its range, the number that appears the most often. So then we're not perform the merge that fast enough anymore. Yeah, that's. Wait a second. I guess here we're learning together. Okay, use a different. Left index. What? Oh, okay. I mean, I never learned most actually, and apparently you didn't need to get to be a red top coder back then. So I think people are just pointing up ideas and they're just doing crazy things just because they can. Because I feel like it's one of those things where once you learn it, it's not interesting. So I don't know why. So I don't bother learning it the first time because it's not interesting as a problem solving thing in general. Maybe this is though. I'm just saying in general. There are a lot of things like that. Okay. Okay. So it's saying that we store the results for each block, and then because we only kind of grow left and right into the adjacent blocks, oh, I mean this code here, which maybe is a little bit too whatever, but I'm trying to just understanding it first. And this thing still doesn't load. Alright, fine. We have 9 minutes. Man, this is very short detail. I mean, they give it an idea, but they don't really explain it. We will first. Left index is in. Okay, I mean, that's fine. We can sort the queries, we can pre-process the queries, that's easy. Right index of the queries, that also feels fine. Oh, because then you always just grow, and then you could skip ahead either one element at a time. Okay, I mean, I kind of get it, but how does that stop it from? I mean, I guess the square root part doesn't. It's confusing to me necessarily. Or like, where's the time saving coming from if you just start with one block and then just kind of keep extending? I mean, the idea is fine, and then you go to the next query, which I guess you shrink on the left side, right? So the left side will always keep shrinking, but then the right side you also want to shrink on the right side. Oh, but then I see, because you can shrink. No, but then you just keep going, right? Oh, you kind of make. I guess one way you could do. I think you could subtract from the blocks and then go again, but if you do it that way, I don't know how that's not n squared though. I guess that's the problem. Yeah, we know how to do that. I mean, I basically wrote this already, honestly. Of course, that's what we're doing. Okay. Oh, I guess this is the part that I was confused about, that they're answering. I mean, my confusion about this is then, like, where does the pre-processing help? Do we even pre-process? This part is fine. What's this again? Oh, yeah, that part. Okay. So we don't even have to pre-process. Is that right? I guess that's the part I was confused about. All right, let's try it. We have 6 minutes. We're not gonna get it, but that's fine. We already submitted a couple of times. Though Leetcode is very bad about. Leetcode is sometimes very weird about, like, when my time ends, it goes away. So okay, so then now we want to say we want to sort by a block, right? So right, so block is equal to say square. I actually don't know that algorithm. I'm not gonna lie. I think I know square root decomp in general, but not the Mohs algorithm. Apparently, there's this proof. I mean, SL makes sense. I still don't know how. I mean, the left side I get, but I still don't know how the current right part move. Because this could go all the way to back to the beginning, right? Like, can you just go like back and forth and back? I mean, you probably sort it, but so that you just kind of go sweep, but then. Oh, yeah. I mean, this is the thing we're talking about, but I still don't get how the right movement part. Oh, wait. I guess I missed this part. All the blocks have been left. So then Oh yeah, this is S and oh. Oh. Wow, that math. Okay, I'm just really bad at math. Okay, I get it. Because you go, because there are n. It's not n elements. It's n over square root of n elements. And so, because you're only doing it on, so then it's gonna be n. Oh, that is. I am not a smart boy. I guess that's what I'm gonna say. We have 3 minutes. We're not gonna finish this. It's fine. We learned something. This is kind of cool. I don't know that. I mean, I didn't know it, but yeah. Can I rewrite this in a good way? All right, let's just say, okay. Maybe we have something like t increment, right? I'm just basically copy and pasting from this. And what I want is, yeah. What is T? I don't think I need T. What would I have T for? Okay. Okay, so that's basically what I want. Don't need this anymore. And in fact, I've already submitted it, so I don't think I need most of this anymore. Okay. And now we want to sort the queries in order. So we don't even do the square root decomp by itself. Okay. Box size. I guess within the box size we can sort as well. So basically we want to, oh, we have to sort the queries by that, right? Okay, yeah. Never learned it. But any idea that you can learn in like 5 minutes and then solve the problem means that the problem setter is, this is not a good problem, if you ask me. Okay, yeah. Let's call it queues. We want to sort by, I guess it doesn't matter. I mean, it matters, but there's no natural sorting order. So we want to do, what am I writing? What is that? So we want to sort by the block order. Put in a function, maybe. Yeah, okay, let's put in a function. And it's just return x. So block of, I guess I could have done that actually. X of 0 is to the left, and then there's this like weird alternating thing, right? Which honestly, I don't even want to optimize. It's fine. We don't have to. Well, we still want to sort by from going from left to right, so that's fine. Yeah. I mean, we'll do a little bit of resetting. It's not optimal, but it's fine. Okay. So then now, yeah, we worry about correctness for now, and the contest just finished, and I didn't finish it. Oh well. But I guess I learned something today, so that's good. It's always what I'm hoping for, something that I can learn from. Okay, and you know, and now I know some people ask me how I learn stuff, and this is how I learn stuff. Like I look at the idea. I don't look at the code that much, But once I look, then I try to implement to my best understanding, and maybe my best understanding is wrong. So okay, so sort by block size. Yeah, that's clever though, because the left side only moves because they're on one block. The left side moves at most of n altogether by definition. Well, I guess within the same block size. Huh. I'm trying to think. If we're sorted by the same block size, why would we not just... I was going to say, why don't we just sort by x sub 0 and not block? I mean, why does the block matter? But the block matters because you want to group you want to sort by the right side because this thing is not as interesting as because you want to group them. Wow, I mean, that's such a... I mean, it's named after someone, right? Mo. Is Mo a person? So, okay. Yeah. Okay, what else am I doing? Okay, so now we have the queries. We want to answer the queries. Okay, we have everything set up, right? So then now we have for left, right, threshold, index in QS. Okay, right. So then now we just start by and we can start by saying, I don't know, the current left is equal to just the first one, really. I mean, you could set it to 0 too, I think, but maybe that's fine. I don't know. But we just set to the left of the first element, so then we can just grow the first one, right? So then now it just becomes a straightforward thing, right? Because then now, while L is greater than left, or may have to worry about off by ones, but that's fine. So while L is greater than left, then we just decrement by 1, and then we add L. No, L is already included, so we subtract 1 and then we add it, right? So then instead we have update num sub L with +1, right? And now, well, okay, expand, right? So at left and right is inclusive. No, it's not inclusive because that otherwise, I guess maybe this should be this to contain no. Now it is inclusive. Okay, I like it inclusive. Okay, so then while left is less than left, I think technically for it to be inclusive, this actually removes first. Is that it? I mean, it's such a silly problem. SL of the max element and maybe negative, right? And that's it. Hopefully. This is, no, that's right. Is this right? I mean, the first 3 is right. How long did that take anyway? Yeah, no time. Oh, it's the wrong answer, so not so bad. Oh, I forgot to do the threshold thing. Okay, fine. What again? count and x is equal to, okay, so if count is greater than equal to threshold, then answer index is equal to negative x, else, okay. I get it? It's hard to tell. Okay. Alright, let's give a YOLO submit. I mean, I expect this to be well, honestly. It's my first time just coding it from learning it like 5 minutes ago or whatever it is. So, got a wrong answer. That's okay. See what we're wrong at. Oh, timeout. Okay. So maybe we do need to make that optimization. I'm just trying to see whether I have any obvious optimizations. I don't think so. I mean, like this one, we do, but yeah, so maybe we could do some optimization here. Because, okay, I mean, it's such a unnecessary, I don't know, it just feel like it's not in the spirit of things, but how do I want to write it? Okay, so basically, if we can maybe do something like right if block something like this, right? I mean, it should still be right for sure. Is it fast enough though? I don't know. We only missed by 5 test cases, so maybe that's just fast enough. This is a big case though, big boy case. And that's good because if it, I should have tested, I mean, well, no, it is after the contest. I don't care that much anymore, but it's still too slow. Am I missing some critical? Missing by block. Equip them by block, okay. I mean, this part is sketch for sure. But no. I don't know how to figure the timing out because I don't know this problem enough or this algo enough. Let's see. Q dot square root of f of the remove functions. Okay. Yeah, I remember seeing this, so, but yeah, I mean that's basically what I implemented actually. Well, this is a comparator instead of a key-based thing, but the sorting is not the part that is killing the time, though. It is probably this thing and probably as a result of these things. Am I doing anything crazily wrong? Don't think so. What is n here? With 10,000? So 100 is the box size. I guess it just doesn't show. Okay. I just want to check real quick if what the timing is on the other components. I don't know why this is so long though. So definitely Leetcode maybe just having issues in general. Like this should not be time limited, so maybe something else is wrong, right? Oh no, this is not pass. This is a brick. Okay, never mind. I'm just being dumb. I am the one who is wrong today. Okay, so that is pretty fast, but that's nothing, of course. But that means that, okay, so then just want to double check that all the other stuff is okay. This means that this is a little bit slow, which is unfortunate. Like maybe we could cache this, but it doesn't even matter, right? Because even on the other thing, it doesn't change anything. So I don't think that's quite the reason. It is all these updates that is the reason. Am I doing it wrong? Actually, yeah, I mean, this is basically first principles, right? So I don't know how to do it quite better. And this is the compiler. I mean, I guess it's just Java time. I don't want to spend too much time trying to figure, because I did all the obvious stuff. Maybe use a, I mean, in other languages it's way easier, right? Because we don't need because I think map already wait, let me ask. Oh, map sorts by key. Okay, well, let's take a look at this ChatGPT C++ solution. Is it at least right? Okay, YOLO submit. I'm too tired to even think, but it doesn't time out, so. Okay, so I would have been annoyed. Oh no, time limit exceeded anyway. Okay. What am I missing? Oh no, accepted. I don't know. So okay, so the multiple silly solutions on this one, or not solutions, just situations. Can I get this in Python? But also, like, this is so template-y that I don't even know how to think about it. Let's see. I mean, I'm trying to see whether even with the cheaters there's a Python solution. I mean, this. Okay, oh, there it is. That's crazy. I mean, they clearly know the algorithm or Google the right algorithm, but their best algorithm is not even a heap. It is just looking at all the items. How is that fast enough? I mean, I guess so, but why? Is the idea faster? I don't know. I mean, I could see it, I just don't. Okay. I mean, writing it like this does not make you cool. Though I guess my code is not that much cleaner. I mean, you know, you cheated anyway, so I don't know. I'm so cynical of these days. Maybe he didn't cheat at the time, but I mean, it's very believable that people didn't cheat for this one just because it's Googleable, apparently. So yeah, that's why I wanted to write a heap, but I mean, that would be faster, but it's just lazier for me. I don't know. That's all I have with this one. I am too lazy to kind of figure out how to do it in Python. I'm tired, rather. I still gotta go for a 5-mile run. Anyway, that's all I have with this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.